Hi everyone, welcome everyone to 2020 APAC Groundbreakers Virtual Tour by APAC OEC. This year our event would be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages. Please remember to register as many sessions as you can, and all sessions would be available to replay as many times you want 2 weeks after the initial session date and time. You can also interact with speaker at any time during 2 weeks by posting questions or comments directly in the playback session page. With that, we would like to thank you all our uh, user groups, Java user groups, Oracle user groups, and also our sponsors, Groundbreakers and CloudDB, for making this event possible. So today we have Sanjay with us to present the simplicity of converged Oracle database for building microservices. And if you have any questions, please post in Q&A chat tab, and the questions will be taken at the end of the session. Thank you so much for joining, and Sanjay, over to you.
All right, thank you for the introduction. Welcome all. My name is Sanjay Goil. I am based out of Redwood Shores. And let me share my screen first, and then we can get started. So I'm going to present on the simplicity of the converged database and how to build microservices with it. Right. So again, I think many people are facing the challenges of modernizing applications and microservices, or if you want to call them macro services or mini services, is a paradigm. Right. So we'll get into details of how to build these microservices. Firstly, by starting with a definition. So again, a brief introduction. I lead product management in the messaging and microservices area in the Oracle database team. I'm based out of Redwood Shores in California, and you see it in my background. Our Redwood Shores headquarters of Oracle. So we have 45 minutes or so today, right? So I wanted to kind of maybe give a little bit about data-driven microservices architecture, a little background, maybe share some material with you, because again, it's a large topic, and we have done this over the last 6 to 12 months. Given talks, given labs, and I want you to have some resources even beyond this session, right? So of course the recording is available, but there'll also be some hands-on labs, which there was a session about a week back. You could go view that as well, but I'll also share some of that material here. We also will kind of talk about how to build an application. So we call it Grub Dash. It's basically a mobile food delivery application, and how do you start building that, right? So again, architecture, the labs that you can do on your own. It's a self-service place. You can get a cloud account on Oracle. So all that, we'll talk about that. And then the simplicity of, we'll go some of the microservices frameworks that are out there, things like Spring and Micronaut and Halidon and others. Right? We kind of talk about that a little bit. Hopefully there'll be some time, but please bring your questions in the Q&A tab. I have a colleague who can stop me at any point and ask me those questions. So by the end of this talk, you'll probably learn how to build microservices-based applications, right? So that's kind of important, that you get, take something out of this talk. So we have a quick poll here, right? I wanted to just see, what your primary role in the organization is. So if you don't mind, we can give maybe 30 seconds to get an idea, and then we can share this poll with you. So could you go ahead and take this poll? So we can stop this when we have enough responses.
Yeah, sure. Wait for a few more seconds and I'll stop it. Yeah. All right. It's good.
Can you share the results? I think it allows you to share
Yeah,
as well,
sure. I'll
and
do
we
that.
can maybe
I'll do
see
that.
what do we have,
Yep.
right?
Okay.
So it's a even mix between developers, DBAs, and architects, right? So about evenly distributed. That's great. I think all of you will get something out of this talk, right? Okay, so let's move on. So there are some resources here. There's a Bitly link, so it's called Database House Party. There's some detail in how some of the features of the database that I want to talk about are shown there, right? There are video recordings of these. This was done sometime in June, but if you just capture this link here, it's a small Bitly link, Database House Party. And what we kind of learned there and what the feedback we got was developers want to build data-driven applications as microservices, right? And microservices can become complex quickly, but they can be simplified, right? A lot of times, developers are building almost a database in their mid-tier, right? But if you rely on a persistence layer, a right data layer, the term like data mesh has been used lately, right? So the code, the DevOps, the performance, the availability, the security of the architecture becomes simpler, right? So given that, we also have a Slack channel like called databasehome.slack.com, right? So sometimes you can, if you go there, you can sign up and join the microservices channel on there. If you're not able to join it, but for any reason, you could send me an email. My email is my first name sanjay.goil@oracle.com, which I'll share with you later as well. So given that, again, there's a drive towards simplicity, right? So and the simplicity comes in at all three tiers: the application tier, the data tier, and integration and ops tier. So a lot of effort, 80% of the effort we see is in the app tier, right? People don't really think about the data tier as a first class citizen when they design the microservices. So, and of course, some of the monitoring and the tracing aspects of it, which again become, the ops tier there as well. So we'll kind of see some of those concepts here, and then we'll, of course, as you do the labs on your own, you'll get some hands-on experience as well, and I'll share with you those resources. So first, let's kind of get a definition of microservices that we can work with, right? And I like this one from Adrian Cockcroft while he was at Netflix. Netflix built a lot of microservices, right? They were perhaps one of the first ones. Then, of course, Uber and LinkedIn and some of these net companies came in and said we're doing a lot of microservices, right? So the fundamental principles here were it's loosely coupled service-oriented architecture, right? So we've been doing service-oriented architectures all our lives, but the loose coupling is where you can update a service independently, right? So if every service has to be updated at the same time, it's not loosely coupled. I mean, that's what a monolith is. So you're breaking the monolith, or you're designing new microservices. You're making them loosely coupled, and then again, loose coupling happens with the second part of the definition, which is the bounded context. So if you know too much about your surrounding services, you don't have a bounded context, and a bounded context is basically a business driver, right? Which says, I have a certain action to be taken, right? So if I want to say reserve a ticket, then the reservation is a service. A customer is maybe another service where you have all the customer context and other places, and maybe there is some other microservices around, right? So you can have reservation ticketing system could have multiple microservices that basically are bounded to the function they have. So given the definition, a lot of the architecture comes in this form, right? Which on the left side you see producers of data, web servers, order service, APIs, brokers, mobile, IoT, transactions that go through databases, and a lot of these operational data sources then flow through an Apache Kafka like bus. It could be RabbitMQ, it could be your favorite messaging service, IBM MQ or something, but Kafka seems to be fairly standard out there, which then lands that data into other places, for analytics, for object storage, for a data lake, for analytical stores, and then the consumers consume from there, right? So you can imagine this getting fairly complex with many technologies, multiple data stores, the copy contagion problem that data is copied many times. Every developer says, oh, I want this data to be in this format, this data frame, or Parquet formats, or some other format that, again, makes them use it for the analytical aspects they want, right? And of course, can become complex and difficult to maintain. And you can imagine the skill set being fragmented because not all platforms are created equal. Some of them have SQL, some of them have some variation of SQL, right? So again, these have been referred to as Lambda or Kappa architectures out there. And there has been this move from, where it used to be a database and a data warehouse to a special purpose database, right? So you'll have a database for key value store, or a database for graph data, or a database for relational data, and then have an event hub, and then you stream data to these various places, right? So we believe there's a simpler way to do these things, and that simpler way is through a converged database, right? So the Oracle database now has been containerized, right? So these containers is what you see in the middle, these gray boxes, and the PDBs, the pluggable databases, are it's a database. So each container database can have multiple pluggable databases, and they support natively JSON or numeric data in tables, spatial data, a messaging service called AQ. Some of you may be familiar with that, right? So again, you see a lot of features in the Converged database that we'll talk about, right? And then you can see this flow of data and events coming through the Converged database, and you can scale, of course, with RAC, with sharded databases, right? So you can see the skill set kind of becoming unified here with microservices support, with open interfaces. We'll talk about how the containers and the Kubernetes app tier talks to this, and kind of less to learn, manage, backup, upgrade. So if you're familiar with the database, it actually helps you make it a data tier in some ways. And of course, if you use the autonomous database on the Oracle Cloud, it is also self-managing in some ways. So that's kind of the paradigm of the converged database. So on the right side here you see the characteristics of the data platform, right? So we talked about JSON support, spatial, graph, events. There's machine learning in there. There's blockchain tables available, right? And this, of course, in-memory analytics. So there's a lot of effort here in making it multi-tenant to make it a platform for SaaS applications. SaaS, again, when you talk about SaaS applications, they're also multi-tenant by design, right? So you can have multiple PDBs, and you can slice and dice those PDBs based on access control from application layers, and then kind of talk about your customers at a different security layer in some ways. Right? So there's a design aspect of that is supported. So there are, of course, transactions, and there are transactions. When you talk about microservices, and we are breaking monoliths into microservices, you may ask the question, what about my transactions? Right? So of course, you could do XA, and XA, again, probably not the best design pattern for microservices. There's something called sagas, and sagas are basically transactions across microservices. And these are asynchronous by design, and they can either be using REST APIs. Again, if you go back to the definition of loose coupling, the transaction can span the boundaries of microservices, and you could be either using REST APIs between them, or you could be using messaging. And I think the messaging layer is what we'll talk about, that allows us to make it more asynchronous and scale better. The message APIs, of course, with Kafka, with JMS, right? So again, Java messaging service has been a very popular API which is supported, and we're also bringing in Kafka client support into some of the AQ and the TEQ things that are getting introduced. On the left side, you see the app platform, where again coding in Java, Python, Node. You're using microservices framework like either a Helidon or Micronaut or Quarkus, some of these things that are out there. And we will talk about these frameworks towards the end, but you could use a framework that allows you to do annotations, and those annotations allow you to do tracing and health checks and other things, right? But fundamentally, you have uh, a Docker image that then gets managed by Kubernetes. You can have a service mesh running with Istio, and then of course tools. Open. These are a bunch of the CNCF tools, the Cloud Native Computing Foundation tools that are pretty much becoming fairly standard and are also offered on multiple clouds in some ways, right? So that stack that you develop in is fairly open, and a bunch of these things, when merged with the Converged database, build a great microservices architecture. Again, when I say great, I mean simple microservices architecture. So when you start to think of a stack that comes together with the pieces you saw on the previous slide, you see, it could be a public cloud or it could be a private cloud, right? Private cloud could be a hybrid in your data center, or a part of a public cloud. So there's an Oracle Cloud Infrastructure. Of course, you're probably familiar with it by now. If not, we'll talk about it a little bit. There's also the Oracle Linux Cloud Native Environment, right, which is basically a Linux stack that has popular tools built into it, right? So it's got Kubernetes engine in there. It's got some Grafana, Prometheus, and all that stuff. So you can kind of start building these things there. So the labs we talk about are on the cloud today, but we also offering these labs for you to kind of get hands on keyboard on the private cloud as well, with the Oracle Linux Cloud Native Environment. What they give you is basically a way to have Docker containers, have Kubernetes installed, and then have a service mesh concept, and we'll talk about that a little bit. And of course, the data layer, right? So the autonomous database, and of course, you can use Exadata or some of the services that are now available not only on the Oracle cloud but on any cloud, right? So you can basically run some of the database services from any cloud, but also cloud at customer in some ways. At the top, you see, of course, traditional applications coming in. You can have your Java microservices with Helidon, with Graal, again, a lot of Java code, Polyglot, again, in Python, Node, and Graal allows you to do some of these conversions across these polyglot microservices. And of course, there are serverless microservices with functions and an API gateway on the Oracle cloud, right? So you can, we don't talk too much about this yet, but I think this is a pattern that is fairly popular out there. We have been focusing on data-driven applications where data layer is fairly important, but a lot of these serverless microservices are ephemeral in some ways, and they are popular in terms of generating action, running a model, taking decisions, on the fly in some ways. On the right, you see a stack that would do monitoring, tracing. So again, observability and tracing is very important as you go into DevOps area of deploying these microservices at scale. So let me just skip this poll because we did set this up, and it's probably hard to ask you to raise your hands. But again, I'm hoping you ask this question to yourself: where are you in the journey, right? So what stage is it? Is it, if you're already deployed many microservices, some of these concepts may come to play, like, because a lot of people go down the path and then they, realize maybe I haven't taken care of the messaging layer or the data layer. I was too focused on the app tier in some ways. So again, there is, some learning to be done there. You're implementing, but struggling in some ways. I know we hear a lot of people coming back and saying, we just don't know how to think of all the three layers together. And of course, there are people who this is the right stage to be learning about it if you're interested, but not planned yet, right? So again, you can plan better. And if you're not interested, you should probably pay some attention to modular design, microservices, and then see how to take it forward. So whatever I've said of the stack over the last few slides, there are three personas, right? Again, people on this call, developers, architects, DBAs, right? So developer is basically looking at, either building a new application or transforming a monolith application, right? And you can probably be thinking about it being on the public cloud or on in your own data center or on a combination of these two, right? So again, hybrid cloud, multi-cloud, many vendors are coming in and saying, let's do it everywhere. But again, it depends on what you want to do. Some of these techniques are uh, open enough for you to take across, various deployment paradigms. So the business workflow is what a developer thinks about, right? What am I going to do as I put this application together? The microservices framework then allows you to uh, put in some annotations that allow you to then, either think about your application tier and your microservice. How does it scale? How does it trace? How does it do long running actions? Like if there are transactions, there's Eclipse framework that allows you to do these saga type of things that I was talking about earlier. And there are many other aspects that are coming in these frameworks. Again, I show Helidon here, but it could be any other thing that supports Java, right? So there are many Java frameworks out there that do this thing. There are a few that do, like Django and others for Python, but maybe they haven't put in things like LRA and other things yet, because they don't see the need for transactions yet. The other aspect is data modeling, right? Where of course there is data dependencies, and if you have a monolith, you have a lot of dependencies that are cross dependencies from various functions within the application, right? So this is where, as you are making the bounded context determination, the data modeling comes into play, right? So then this is where you start getting into architecture of it as well, right? So the three aspects of business workflow, microservices, data modeling, are a developer kind of collaborating with an architect. When it comes to the architecture, the microservices is in a container, and here I'm showing Istio. Istio has a sidecar, and the sidecar basically has this networking, security, policy thing that your developer has for the microservice doesn't have to think about, right? So you've isolated only the business logic in the microservice. The sidecar takes care of the rest of the stuff, right? And of course, the service mesh can then recognize services on the cloud or on premise, and then work with the data mesh, right? So the data mesh is nothing but, in this case, a data layer that allows you, in this case, the Converged database, right? So with JDBC connections, you can use Connection Manager. There's a bunch of aspects that allow you to have your own PDB per microservice, or a schema in a PDB per microservice. So it depends on how you want to isolate other things. So, but again, the PDB architecture becomes quite easy, because a container database can have tens or hundreds of PDBs, right? So, and these PDBs can span across multiple CDBs, multiple availability domains, to get your architecture to be resilient, to be uh, have reliability built in, right? So, and then the tracing and monitoring allows you to make it more and more autonomous over time. Autonomous basically means automation, but also intelligent automation, right? So decisions can be taken to scale up, scale down when capacity is needed for a particular microservice. You don't have to scale everything all the time, right? So if your orders are coming in, then the order microservice can scale. Now, of course, that may mean that your inventory or your delivery microservice also needs to scale with that, right? So, but they may scale at a different size, different tier in some ways. So that's is where the collaboration between developers, architects, DBAs becomes quite important. And many analysts, like Forrester and Gartner, basically say a lot of people do microservices, but they don't get the benefits of it. And then, of course, they start to come back and say, maybe we are better off doing modular monoliths, right? But what they miss out is the advantages come when the three roles interact with each other, right? And there is a common language for them to talk to each other to say, here's the data architecture, here is the service mesh architecture, and here's the developer data model that allows us to make things simple in some ways, right? So again, simplicity is the goal. Hopefully, there will be a platform like this someday, but these are early days in microservices where we're putting these concepts together, and you'll see that a bunch of other cloud providers are also going down this path. So, quick note on bounded contexts, right? So we talked about the definition where you have loose coupling and bounded context, right? So bounded context is, in this case, you see a sales context and a support context, right? So in an app, there where you're talking about the same customer, a product, right? So the sales context is there's a territory serves a customer, has a product, as a salesperson. Again, you can see these dependencies happening on the sales context side. On the support context, it could be a ticket, and that ticket, of course, has a customer, has a product, has a defect, right? So you can kind of see how to do this. Now, of course, you are starting afresh. You can draw these boundaries and then say, where is my data model, where is my app tier, and how do they uh, interact with each other. And if they want to reach out to separate service, then can they do REST APIs or can they do messaging, right? We'll look into all that. So designing of microservices within the bounded context, there's certain business processes that are implemented, the logical boundaries, and okay, you can split the monolith database along the lines of bounded context. Now, there would probably be, it would be better if you had a tool to do this, and then we are building something around this area where we can look at access patterns of queries to tables and then kind of come up with some analysis and visualization that will allow you to kind of look for these bounded contexts. And if you have this problem, if you have a domain, please reach out to us that we can get your input in that product design in some ways, right? So enough said about that. So again, maybe data consolidation slide here, right? So bounded context makes it easier because now if you have multiple data types and they were in different databases, the bounded context problem becomes quite hairy, right? So in this case, if your data was in Mongo or in Postgres or in Cassandra, how do you actually define these bounded contexts, right? So what this shows is the Converged database, as you bring these data types into these PDBs, right? So you can have the tabular data, spatial data. You can build relationships between these things, referential integrities and other things within the same database. So the converged data types, the virtualization, consolidation of data in these PDBs is a very powerful concept for microservices. The second is on the right side here, the converged query, right? So you see the unified data model, and as you're doing, maybe analytics, you can write very complex queries that take spatial or graph or JSON or relational data into account, and you also have a embedded messaging service in there, right? So the holistic view of operational data becomes quite important in this near real-time world. And of course, you can program it with SQL, PL/SQL, Java, Python, Node.js, with APIs that are being used in the data tier. So communication across microservices. So we talked about bounded context, and this second thing is loose coupling in the definition of microservices, right? So then basically, when they're loosely coupled, they also need to talk to each other, right? So there's of course synchronous thing that some people prefer for if you're doing simpler microservices, smaller, a few microservices, you don't want to set up messaging or you don't want to run a broker, then maybe REST or gRPC is probably okay. But you want to scale further, you have tens or hundreds of microservices, then again, this whole idea of loose coupling with immutability of messages is then done through events and messages, right? And you could use a pub sub type of infrastructure. Kafka is one. there's a built-in Oracle AQ, advanced queuing, that can also do these things. And we'll talk about the event sourcing pattern in microservices as well. So what happens here is that two microservices can talk to each other through this event broker. And in this case, you see an order service gets an order from the web. It persists the state change in its PDB, in its local PDB, and then publishes this event. Right now, this is a transactional event, which of course has its own advantages that developers can use. Right, they don't have to worry about duplicate messages or things getting rolled back and replayed, and you having to filter those things. And we'll talk about the transactional messaging aspect here. But then the inventory service is listening to the messages on this event broker. So an order gets placed, it persists in the change, the event gets read by inventory service, the inventory service checks its inventory, can I satisfy this order or not, and then puts another message back, which then goes back to the order service. So these services are listening to each other's messages, or listening to the event broker. And this event store, so all events are then stored. You can get back to the state of the universe if you look at all the events, right? And the event sourcing aspect is that any event that happens, right, even putting a data in the database, or again, the same data that went in here also went into the event here, right? So you're basically getting all the events getting played out, right? So that's what event sourcing is, where the eventing bus kind of becomes the keeper of all the information as it goes. But here we use it as the messaging service between microservices. So here's a look at the transactional messaging that is provided in the database, right? So this AQ, or we are also now calling it transactional event queues. So what has happened to AQ, if you're familiar with it, is that it has also been partitioned. So you can partition the queue table, and if you're familiar with topics and partitions in Kafka, very similar to that. And each partition queue table is an event stream, right? So you can basically do key-based eventing, or you can address, a particular producer and a particular consumer on a particular event stream in a single queue table in some ways. But more importantly, combining a DML and an event in a database transaction. So again, it's transactional. So in this case, the transaction T1 wrote an order in its PDB. It sends an order message and commits, right? And this then gets written in this database. It also sets up message propagation with DB links internally, and then here the inventory DB receives that order, checks inventory, and sends a response, right? So this only sees this when the commit happens. If it rolls back, this message is not seen. It is replayed, and it's only delivered exactly once, right? So again, the guaranteed delivery, and of course you can create chained event flow driven workflows easily. Slightly different philosophy than Kafka's dumb brokers and smart consumers, where they put a lot of onus on the consumers to do some of these things, which makes the app logic for error handling complex, right? So again, part of the simplicity of using this is that your code becomes simpler with transactional messaging. We talked a little bit about the service mesh earlier on. Again, Kubernetes takes care of automating application deployment, scaling, and management, but there's still a lot for the developer at the data plane level and the control plane level, right? So at the data plane level, they use something called Envoy, which is part of Istio, and it's basically a sidecar proxy that do service discovery, health checks, routing, load balancing. There's a lot of stuff that happens in these sidecars, and of course, the Istio allows you to then set policy, configuration, and other things as well. So there's a lot of work in the service mesh area. So if you are not familiar with it, you should look at Istio or Linkerd. There are a couple of these things that help you put these things together. And in the labs, you will see them as well. The Second thing is around observability and distributed tracing. So, here you see tools like Kiali, Jaeger, and Grafana being mentioned. So probably you're familiar with Grafana more than the others, perhaps. Right, so the Grafana, you have the ability to display your time series, metrics in some ways, right? So you can basically replay, replay them when you want to, and you can kind of go back and kind of see where the error occurred and how do I go find out what happened when. And open telemetry with Jaeger kind of gives you the tracing between these microservices, right? So you can see some of these things where a service took this long and then it called some other service, right? So you can kind of see some of the time dependencies in these things, and sometimes something that takes milliseconds can take seconds. You can isolate that, and then that goes back to, so Jaeger is connected to Kiali, which then looks at the call graph, right? So these are the dependencies between what service calls what service, right? So here an order service and inventory service, and how they interact with the front end is shown, right? So you can basically now on an operational level look at your microservices, right? And open telemetry with open tracing and open census, there's a bunch of standards kind of coming out there where you can look at spans and traces and other things. So there's a lot of exciting work in this area that needs to, of course, come together. And this is where we are showing you some examples. But I'm sure over time you will see more integrated app performance management that does this at the app level, but also does at the data level, where once you made the JDBC call, what happens in the database is not just a black box, but you actually get metrics out of that as well. So let me start to wrap up, because I think we have about 6-7 minutes left. So the next piece here is around, okay, all this is good, but how do I get my hands on to something I can touch, feel, and play with, right? So we put together a Grub Dash microservices architecture where we have 3 services: an order service, an inventory service, and a delivery service. And I'll show you what it means to put this application together. They run in their own Docker containers. They're managed by Kubernetes. We use Helidon MP, and of course we write it in Java, and that code is available for you to play with, to then take it to modify and build your own applications. And then they use PDBs, right? So they use, each of these services use their own PDBs. We show text data, we show tabular data, we show spatial data, and we show messaging that is all inbuilt into the Oracle database. Right, so each service is a container, PDBs per service, event broker, Halidon, spatial, graph text, and then we also show some patterns of Saga, event sourcing, and CQRS. Right, these are all patterns for microservices. So if you read the Gartner report on microservices, it's actually a good one, which kind of talks about some of these patterns out there. So this is what GrabDash looks like. So again, I took this from DoorDash, which is again, mobile food ordering app, at least in the US, probably available elsewhere as well. But you can think about it kind of, in your own country, whatever that app is. A consumer places an order, the order checks inventory. If the inventory is there, then the order sends a message saying to the delivery service. The delivery service then takes an address and delivers it, right? So again, we are looking at the core of the service, and of course, there's a lot of AI/ML that can be done. And of course, we keep on building these labs. We are showing more and more functionality. We're bringing in machine learning. We're building in blockchain tables to show, farm to table assurance and other things. We're trying to do machine learning to show you how to do wine and food pairing, for example, right? So using reviews and other things. So text mining in some ways. There's a lot of opportunity for delivery optimization, using graph data, right? So if multiple orders have to be delivered to multiple customers, you can think about it as nodes and edges and all that to optimize a route or something else. So this, again, this framework allows us to build more and more functionality to show uh, customers, developers, architects to build applications. So this is the setup, and I'll show you how to reach these. Lab 1 sets up Docker, Kubernetes, the database on Oracle Cloud. We have some on-prem infra setup. If this is not available out there yet, if you're interested, you can drop me a note. I'll make sure that we reach out to you when this is available. But right now, you can get your hands on to the Oracle Cloud. We have some code in GitHub. We have a container registry, and then we set up the queues. We set up Helidon and all that, right? So lab 3 basically infrastructure, and then there's walkthrough of the microservices setup. And I think in the last minute or so, I can show you what that setup is. There's a UI that allows you to kind of look at some of these patterns. So the microservices aspects are in lab 4. A lot of time, at least an hour and a half, goes in setting up the lab, right? So setting up the infrastructure. But once the infrastructure is done, you can walk through the setup. You can then also uh, do polyglot services. So we show you how to replace the Java code that is with Helidon NP with Python for the inventory service or Node.js, right? So you can think about the services now. Some services in Java, some in Python, but they can talk to each other with the same AQ infrastructure. We also show you app and database scaling, right? So again, as more and more orders comes in, how do you get more instances for the order service? We show you how to scale the database with ATP, the autonomous transaction processing database. We also show you how to build an Apex app, which gives you a quick ops dashboard, right? So these are 7 labs that probably will take 3-4 hours, half a day or so, and then we continue to build some of these things we were talking about with the Yelp recommendations, how to place your order or how to do spatial routing. Again, we have done some of these things, but we haven't really put the labs out there. We're working on these we brought out. Last topic is basically microservices frameworks. There's the full stack one, which again slightly heavyweight but very popular, Spring Boot out there. Maybe some of you are using it, some of you have heard of about it. But again, there are things like Micronaut that are similar to Spring Boot, but are lightweight, faster, and all that. So again, I think that's something happening there. The microprofile based ones are the Eclipse microprofile ones, so Quarkus, Helidon MP. They are familiar, if you're familiar with Java EE, those are the frameworks to kind of focus on. And then there are some reactive frameworks like Helidon SE that can also, have reactive messaging and, very, very fast serverless type of stuff and all that, right? So this is like micro frameworks that allow you to do some of these things. Again, I think I talked through about these things, micro framework, reactive style, there's a declarative style, familiar to Java EE, and of course, they're all using Graal VM, the database and messaging, and long running actions and sagas. We talked about this earlier on, right? So there's some deeper dive to be done here. They're basically in Helidon microprofile annotations. There are these annotations that allow you to trace something, time something, count certain things. You can consume, you can produce, you can do tracing on a path, and then you can do liveness checking. You can do incoming messaging, outgoing messages. You can do long running actions. These are all things that are available, right? And they are also used in the applications. So when you see the code, you will see some of these aspects. So let me summarize and then maybe show you one screen at the end, right? So hopefully in this last 45 minutes or so, we've seen the simplicity in developing microservices for modernizing applications. Again, there's a simpler way than the regular Lambda Kappa architectures that you probably hear about it, because there's a lot of complexity in moving data. So loosely coupled service-oriented architecture with bounded context, right? So loose coupling and bounded context. Hopefully, you learn a definition of microservices that you can, think about. You can, share it with others. The Converged database as the persistence layer allows to be simpler because you can run more complex queries when the data is together. And then the transaction messaging allows you to have simpler code because the logic of the consumer becomes simpler and using the event store. And then the held on NP and AC models again allow you to move from say the Java EE side to Helidon NP, or if you're moving from Spring or something, you can consider Micronaut as a faster framework, right? And then these labs are available at this Bitly link, like Simplify Microservices, right? And if you take a note of this will take you to uh, again, you can do these labs yourself. You can get a Oracle Cloud trial account. You get $300 free credits on sign up. Oracle.com/cloud/free should take you there. And the service, that Simplify Microservices, this Bitly link at the top here will take you to our workshop. So you can launch this workshop and you will basically see uh, the lab, right? So this is lab 1. You set up the stuff. Lab 2, lab 3, lab 4, and 5, 6, 7, right? So this is something that you can do on your own, right? So again, self-service. If you need help, you can join that Slack channel that I kind of had put together earlier on. And I know we're a little over time. I can quickly just maybe show you that there will be a, when you do lab 3, at the end of lab 3, you will get a little bit of a UI that can then show you how to place an order, how to show an order, add inventory, remove inventory. So those instructions walk you through what you have set up as microservices. You have Kubernetes running, you have microservices running, you have event bus running, right? So you have all those things running, and this allows you to also then look at tracing and metrics and other things. And you can also look at Jaeger screens, and you can kind of look at tracing of the services and spans that we saw in the slides as well. So let me stop here. And I don't know if there are any questions. I probably haven't seen any questions so far on the panel, but let me stop sharing and see if there are any questions that you have.
Yeah, we don't see any questions as of now. Okay, so that's all, folks. So thanks, Sanjay. Thanks so much for your time, and thanks to participants also. And the session will be recording will be shared in the portal as well. So thank you very much, and see you in next sessions.
All right, thank you, everyone.
Thanks,
Bye.
Sanjay. Thank you. Bye bye.